things we're going to be doing today is solving absolute value equations, which means you have an absolute value and it's an equation. And I'm going to color code things here. First of all, they drew the graph of the absolute value of 2x squared minus 4. A reminder from last week, how do we graph absolute value ones? Well, first you would graph 2x squared minus 4, which would, that would loop down there. And then wherever the y values are negative, so this dotted orange part got flipped up. Now, if you were asked to solve, where is the absolute value of 2x squared minus 4 equal to 4? Well, y equals 4 is a horizontal line right here. And it intersects the red graph at 3 points. At -2, at 0, and at 2. And just a quick check, if you plugged in 4, if you plugged in -2, well, -2 squared is positive 4, times 2 would be 8, and 8 minus 4 is 4. Is the absolute value of 4 equal to 4? Yes. That's why it intersects at -2. When we check the next intersection, when x is 0, you plug in 0 for x. Then I would get 0 minus 4, which is -4. Is the absolute value of -4 equal to 4? Yes. And finally, positive 2 would work as well. See, this question, if it was equal to 4, has 3 solutions. -2, 0, and positive 2. If we had, in purple, y equals 9, so I go up to 9, and I draw that, y equals 9. There's 2 solutions to this, and they look like they're like -2.7 and positive 2.7, but I can't tell exactly from the graph. So we'll learn how to use a graphing calculator or Desmos to do this. We'll also learn how to do it algebraically. And if you had y equals 2, which I'll do in bright yellow, there'd be 1, 2, 3, 4 different solutions for this. And you would have to find all 4 of them. So on the next, or I think this is at the bottom of the page, we can highlight a few things. First of all, we are looking at absolute value equations. And it says we can use graphing strategies to solve this. What we do is we graph both sides of the equation separately. So I'm going to color code this. I'm going to take the one side, which is the absolute value of 2x, in red, and I'm going to take the other side, which is the 4, in green, and they match up to the green graph and the red graph here. If you graph them separately, there's going to be 2 points, in this case, where it intersects. And it intersects at the point -2, 4 and 2, 4. That tells us our solution is x equals 2 and x equals -2. Because the original question doesn't have y's, so we're not worried about the y part of the solution. We're worried about the x part of the solution. And we can double check and plug these in and see that it works. So today's lesson is going to give us that chance to practice graphing and practice solving. So it says solve by graphing. So I'm going to color code things. The left-hand side is the absolute value of 3 minus 6. The right-hand side is y equals 6. And as I start to graph this, I'm like, y equals 6, 1, 2, 3, 4, 5, 6. That's the easy one. I'll start with that one. The y equals equation is always a horizontal line going through that y value. But to graph y equals 3x minus 6, we have to remember from last week that first you would graph the inside. So I'll do that in orange. Super lots of colors happening. 3x minus 6 is a line with a y-intercept of minus 6 and a slope of 3, so I go up 3. Up 3 over 1. Up 3 over 1. Up 3 over 1. Up 3 over 1. It has a straight line. In absolute values, it's really important to label your x-intercept at 2, 0. Because when I graph the blue graph, wherever it was positive, that stays the same. And wherever the orange graph is negative is going to get flipped up. So this point on my orange graph, which was at 0, minus 6, is going to show up on my blue graph at 0, positive 6. And now there's 2 points that are in common, 0, 6, and 4, 6. So our solution to this question from the graph is x equals 0 and x equals 4. Now we're also going to learn the algebraic way to solve these, and you're probably going to like the algebraic way better than the graphing way, because the graphing way takes a lot of time. Right? The y equals 6, that was easy. But the absolute value part, first you had to graph it below, then you had to flip it up, and then you'd have to find out where they intersect. And sometimes they don't intersect at nice points. So then you spend all that time graphing only to be like, oh, I have to use a calculator to figure this out, or I have to just guess. So I'm going to show you the algebra way to solve these as well. So we had 6 equal to absolute value of 3x minus 6. And with the absolute value, if you think about the piecewise functions that we had, there's always 2 pieces to it. And each piece might have different solutions. So we have the one piece where the 3x minus 6 is positive, and we have another piece where the 3x minus 6 is negative. Because those are 2 possibilities. Does it make sense that this 3x minus 6 could be positive 6? If it is positive 6, it would just look like that. But there's also the possibility that this inside could have been what? And still equal 6 in the end.
Negative 6.
Could also have equaled negative 6. And then it would still be 6 in the end. And it gives you 2 equations. And if we solve those 2 equations, sometimes I draw a line in between. Right? How do I solve an equation like this? Well, I combine my like terms, so I'm going to add 6 to both sides. And divide by 3. There's my x equals 4 answer. And on this one, if I add 6 to both sides, I get 3x equals 0. Divide by 3. There's my x equals 0 answer. Which is really nice. Because that's quicker than drawing your graphs. But there's 2 possibilities. And I hope that makes sense, because the inside could be 6, and then the absolute value wouldn't matter. Or the inside could be minus 6, which would make it positive in the end. Gives us 2 different possibilities when solved. All right, I'm going to get you to circle questions 5A and 6.